Cofferdams are temporary structures used in construction to hold back water. They create a dry work environment in areas that are usually submerged. Imagine building the foundation of a bridge pier in the middle of a river. A cofferdam would be essential to keep the water out. Cofferdams have been used for centuries. Today, modern cofferdams are complex structures. They are essential for a wide range of construction projects. There are different types of cofferdams, each suited for specific conditions. These include box type, braced, cellular, and inflatable cofferdams. The choice depends on water depth, soil conditions, and project duration. Box-type cofferdams are suitable for shallow water and easy to construct. They consist of interlocking steel sheets driven into the riverbed. Braced cofferdams are used for deeper water and need more support. Cellular cofferdams offer high stability for challenging environments. Inflatable cofferdams are quick to deploy and ideal for temporary barriers. Building a cofferdam involves careful planning and execution. The process begins with site preparation. This involves surveying the riverbed and preparing the area for construction. Next, the cofferdam structure is installed. This varies depending on the type of cofferdam. For instance, box-type cofferdams require driving steel sheets into the riverbed. Braced cofferdams involve driving piles and placing horizontal beams. Once the structure is in place, dewatering begins. Powerful pumps remove the water from within the cofferdam, creating a dry work environment. Proper dewatering techniques are crucial. They ensure the stability of the cofferdam and the safety of the workers inside. Finally, after the construction work within the cofferdam is complete, the cofferdam is removed. This involves dismantling the structure and restoring the riverbed to its original state. Section 4. Materials used in cofferdam construction. Various materials are used in cofferdam construction. Steel is strong, durable, and easily assembled. Used in box-type and braced cofferdams. Concrete is strong and versatile. Often used in cellular cofferdams for stability. Timber is traditional and inexpensive. Less durable in marine environments. Impermeable fabrics are for inflatable cofferdams. Quick to deploy and suitable for temporary barriers. Section 5. Design considerations for cofferdams. Designing a cofferdam requires careful consideration of various factors. The site's geology is crucial. Engineers need to assess the soil type, its bearing capacity, and the potential for scour. Water depth is another important factor. The deeper the water, the greater the pressure on the cofferdam. The design must ensure the cofferdam can withstand the hydrostatic pressure. Environmental impact is a significant consideration. Cofferdams should be designed to minimize their impact on the surrounding environment. This includes controlling erosion, preventing sediment release, and protecting aquatic life. Other factors include water flow rates, wave action, and the potential for seismic activity. The design must be robust enough to withstand these forces. Section 6. Applications of cofferdams in construction. Cofferdams are essential for various construction projects. Bridge building often requires cofferdams to construct bridge piers in rivers or lakes. They provide a dry work environment for building the foundations and piers. Dam construction heavily relies on cofferdams. They are used to divert the flow of rivers, allowing for the construction of the dam's foundation and other structures. Pipeline installation often requires cofferdams, especially when pipelines cross rivers or other water bodies. They allow for the pipeline to be laid and welded in a dry environment. Environmental remediation projects use cofferdams to isolate contaminated areas. They prevent the spread of pollutants while remediation work is carried out. In conclusion, cofferdams are indispensable structures in construction. They enable the construction of critical infrastructure in and around water bodies. Their ability to create dry work environments in challenging conditions makes them essential for a wide range of projects.